Hi everyone. Okay, so these last few weeks we have looked at a few different things. I guess the last 2 months. So, first thing that we did, we looked at median, mean, and mode. And we looked at outliers, basically looking at the data. Okay. Then the next little couple weeks, we looked at how to graph that data. So basically, what a dependent variable was, what an independent variable was, all of that stuff. We looked at taking information from tables and putting them onto a graph. We looked at getting information from a graph. Now we're going to be looking at something a little bit different, okay? We're going to be focusing for the next couple weeks on linear equations. But when we're talking about linear equations, we're not just like lots of equation stuff. Like I want you to understand what a linear equation is, what it represents, okay? So that's what this little spiel is going to be about. So we've done this before, right? You've got your data. This is a table. This is the x variable. This is the independent variable. And this is the y variable. So this one is dependent on this all the time. Okay? So for example, if y was seedling height and this was time, time isn't dependent on seedling height, because that means that's like, say your slugs get into your seedlings, like into your garden, and they eat all the seedlings, because that's what slugs do. Okay? That doesn't stop time. Time doesn't stop because your seedlings are dead. No, time keeps going. It's independent of the seedling height. But seedling height is dependent on time. If time doesn't pass, which it does, but if it didn't pass, the seedlings wouldn't grow. Okay? Other things that seedling height are dependent on, like this doesn't have to be time. Seedling height is also dependent on water. So this could be water, the amount of rainfall. It's dependent on sun. So this could be the hours of sunshine. It's dependent on temperature. This could be the average temperature. Okay, so this is always dependent on this. Now, if we look at these things, x is 1. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6. So what do these have in common? What do you have to do to the 1 to make it become a 2? Well, there are two things you could do. You could either add 1 or you could multiply by 2. Keep that in mind. We're looking for something in common. All these things have in common. Okay? So let's move on to here. What could you do to turn the 2 into a 4? Well, you could either add 2 or you could multiply by 2. So here you could either add 1 or multiply by 2. Here you could add 2 or multiply by 2. Here you could, like to turn the 3 into a 6, you could add 3 or multiply by 2. So what have I said for all three of these things? Multiply by 2. What we're going to be looking at is how to represent that. So this says y equals 2 times x. When we're dealing with variables, we don't put a time symbol there, because then it looks like 2xx. Okay, so this means 2 times x. So y equals 2 times x. So if that's true, and I had an x of 5, y would be equal to 2 times 5. Y would be equal to 10. So 10 is equal to 2 times 5. Is that true? Yes, it is. So, we can actually graph this, right? We've graphed this information before. This is it as a graph. So when x was 1, y was 2. When x was 2, y was 4. When x was 3, y was 6. And then when x is 0, y is 0. So we're able to take this all the way up. Okay? You take a straight edge, a ruler. I didn't have a ruler. I know, the math teacher without a ruler. I have a million in my classroom, but none at home because I also have children who do math, who seem to like my rulers. So I took this, which was my straight edge, because that's all I need is a straight edge, right? And I just put it there, line it up against the dots and made sure it went through 0, and boom, that created a line. Now the thing about this line is that it can actually predict what's going to happen. This line represents the relationship between the dependent variable and the independent variable. So if I went, boom, x is 1, y equals 2. X is 2, y equals 4. X is 3, y equals 6. If I kept going with my x's, this line keeps going as well. My x's and my y's, this line keeps going as well. It represents the relationship between the dependent variable and the independent variable. And so what we're going to be focusing on is what we call the slope of this line. The slope of this line. The bigger, the higher the slope, the stronger the relationship. So when we look at this right here, okay, sorry, there we go. Okay, that 2, that is the slope. And so this week, that is what you're going to be focusing on, the slope of the line. Okay, don't forget, you are going to, so your goals for the week, I can recognize if the slope of a line on a graph is positive or negative. And I can calculate the slope of a line from points on a graph or from a table of values. Okay, you're going to learn 2 different ways to do this. So things that you have to do. Watch my video. Watch the 4 Khan Academy videos that I've got. Yes, there are 4 this week, but there's not as much work next week to sort of balance this out. Okay, watch the 4 Khan Academy videos. They are very, very helpful. You've got 4 different definitions for the math dictionary. And then do the IXL practice that is in the content library. Okay, don't forget to attend a Teams meeting. And then also post in the chat if you have any questions at all. I am going to be at the school on Thursdays and Fridays. Okay, so if you're at the school then, you can come and talk to me. But there will always be math people there. Okay, so even if it isn't me, there will be math people there to help you. All right, talk to you later.